Hi, I'm Anna. This presentation is on quantifying recent climate changes. The question is climate change happening the same everywhere? Let's find out. Here you have Station Houston. The trendline slope is m equals 0.03. This indicates that Houston's annual mean temperature has been steadily rising. This positive slope reflects a warming trend suggesting an increase of about 3 degrees Celsius over the next century. The linear equation y equals 0.03 x minus 39.046 shows that approximately 25% of temperature fluctuations are explained in this or by this model. If the warming continues, Houston's average temperature could reach around 23.95 degrees Celsius by the year 2100, nearly 2.25 degrees Celsius higher than the year 2025 prediction. However, since the model assumes a constant rate of increase and accounts only for a limited range of temperature variations, its future predictions should be taken with caution. Here's a breakdown explaining the equations. The trendline equation is y equals 0.03x minus 39.046. Y is the annual mean temperature in degrees Celsius. X is the year. So for example, x would equal 2025 or 2100. This equation model is a linear trend, meaning as time goes on, x increases, y increases by 0.03 for every year. The positive slope, 0.03, tells us that temperature is generally rising over time. So for 2025, let's solve it together. First, you're going to plug in the year. So x equals 2025 into the equation. Now you have y equals 0.03 times 2025 minus 39.046. We're going to multiply first. 0.03 times 2025 equals 60.75. Now we're going to subtract the intercept. So y equals 60.75 minus 39.046. It's going to give you 21.70. So your answer in 2025, the model predicts the mean annual temperature will be about 21.70 degrees Celsius. This is the equation that's used for the upcoming predictions as well. Here you have the Pensacola annual mean temperature trend from the Pensacola Regional Airport Station. The trend line shows only a tiny change with temperature increasing just 0.0011 degrees Celsius per year. The fit is very weak, so r squared equals 0.0062. So this trend line doesn't explain much about the actual year-to-year variation. Temperatures are mostly changing due to other factors, just not time. The model estimates that Pensacola's mean annual temperature in 2100 will be 20.74 degrees Celsius. So what does this mean? According to the model, temperatures won't warm much by 2100. It predicts a nearly flat trend over the century. Since the trend is almost flat and the r squared is near zero, this model isn't reliable for projecting future temperatures. It doesn't capture true variability or provide strong evidence for long-term warming at this location. Here you have Broken Bow annual temperature trends from the Broken Bow station. The average annual temperature in Broken Bow has risen by about 0.03 degrees Celsius per year. The trend line explains just 12% of yearly variations. R squared equals 0.1225. So temperatures still bounce around a lot from year to year. By the year 2100, the model predicts an average annual temperature of about 19.94 degrees Celsius. This is roughly 2 to 3 degrees Celsius warmer than the temperature averages in the 2000s. Because the fit is only modest, most of the temperature's ups and downs aren't explained by trends, so the prediction for 2100 is uncertain. The model shows some warming, but large natural swings and other local factors may make this a rough estimate, not a precise forecast. So here you have a side-by-side comparison. Houston's local climate data and regional assessment both support rapid and accelerating climate change in the area, while comparisons to other sites show change is not happening everywhere at the same rate or magnitude. So you see all three stations compared side by side. Houston's not uniform compared to Pensacola and Broken Bow stations. Pensacola is weak compared to Houston, and Broken Bow is not uniform compared to Houston. So Houston has a strong rise, Pensacola has a flat minimal rise, and Broken Bow has a moderate rise. Now, some questions. Does your analysis support or refute the statement climate change is occurring in your home region, Houston? Houston scatter plot reveals a clear upward trend in annual mean temperatures with a slope of 0.03 degrees Celsius per year and an R-squared value of 0.2499. This means Houston's average yearly temperature is increasing by about 2.25 degrees Celsius from 2000 to 2075. If current trends persist, the R-squared value indicates that about 25% of temperature variation is explained by this upward trend, showing much more substantial evidence for local warming than Broken Bow or Pensacola, confirming warming temperatures, more frequent high heat days, longer summers, etc., which supports the climate change is happening in Houston. Second question, does your analysis support or refute the statement climate change is happening uniformly across the globe? As we saw before, comparing Houston with Broken Bow both show warming, but Houston's rate and model fit are higher than Broken Bow. Between Houston and Pensacola, Houston warms faster, while Pensacola's increase is almost flat. This means climate change is not happening uniformly. Regional climate trends vary in rate, model fit, and underlying causes, aligning with global climate research that shows variable warming, varied precipitation impacts, and local climate response to greenhouse gases increase.